I am Kabita. Today my new React video of computer hardware basics tutorials for beginners. This is video very nice. I found out this video about the computer hardware. I hope you find something to watch this video computer hardware, so share and
As I explained briefly in a previous unit, the hardware of a computer system can usefully be thought of as basically three components. First, you have the CPU, the central processing unit. Second, we have RAM, system memory. And third, we have what are called the I/O devices, input-output devices. And that basically comprises everything else. So say your hard drive, your display monitor, your keyboard, your mouse, everything else other than the CPU and the RAM. And of course these things need to get hooked together, so we plug them all into what's called a main board, or sometimes a motherboard. The main board pretty much is just all about providing a pathway from one device to another, but then also providing power to the components like the CPU and the RAM. This reductive description of computer hardware really does apply to really any kind of computer. So we often make a distinction between a computer which we call a client or sometimes a workstation, and a computer which we call a server. A client or workstation is really just a machine that an individual works at, whereas a server is typically some system that's put in the back room and it's used to respond to requests from the network. A web server, say, is just a computer that's being used to listen for requests for web pages, and when it gets the request it sends the response. There's no hard and fast distinction in the hardware itself between a system we would call a server and a system we would call a client or workstation. Really, the only differences stem from the fact that with a client machine versus a server, you have different performance needs. And so say a server often really needs to have a lot of RAM, so typically a server system will have more RAM than a typical client. Aside from that, client and server hardware are really just some combination of a CPU, system memory, and I/O devices. The same really can be said about what we call handheld systems and embedded systems. Today, for instance, there are some smartphones on the market, like the iPhone, which are mostly made out of components that are pretty much what we were using in PCs just a few years ago. If there's a fundamental difference in the hardware, it mainly again has to do with performance considerations, and especially when handheld devices, with power considerations. In a handheld system running off a battery, you really want to use components which draw a minimal amount of power. With the design of what are called embedded systems, we're also very often concerned about minimizing the amount of power they need, and we're also very often concerned about minimizing cost. So very commonly, say, the CPU in an embedded system is a very old and simple design, like say something Intel designed back in the 70s. Such processors today can often be purchased for just a fraction of a penny. Today, the term mainframe is at best nebulous and at worst really just totally obsolete. The large majority of computers still sold today which are classified as mainframes are sold by IBM, and typically they are systems which are about the size of a large cabinet, and generally they're used as a server that has to handle a lot of traffic or do a lot of data processing. Mainframes have always been used almost exclusively by larger organizations, but even large organizations have increasingly turned away from mainframes in the last 2 decades because they can get the same needs met using just a whole bunch of cheap commodity PCs for servers. Similarly, the term supercomputer is not as meaningful as it once was. A supercomputer, quite simply, has just always referred to a computer that can do a whole lot of calculations, generally because it has a whole lot of processors. A few decades ago, supercomputers were always very specialized hardware, but in the last 2 decades the trend has very much been that you take a whole bunch of off-the-shelf processors which you normally use in just a stock PC, and you throw them all together and you get a supercomputer. Now, getting a bunch of processors to work together in one system is not a trivial matter, but the point is that doing so is not as exotic as it once was. You can do that, in fact, to a degree with today's commodity PC hardware. You can have a PC with multiple processors. Also, it's quite common today to take a bunch of individual PCs, hook them together over a network, and get what's called a cluster. And computer clusters, if large enough, are very often just as good at doing the same sort of stuff we want supercomputers to do, which is usually to do some kind of scientific calculations, like, say, predicting the weather. Of all the components in a system, RAM is probably the simplest, and there's only a few things we really need to know about it. System memory is really just a big bucket of bits, and as far as the CPU can see, these bits are organized into bytes, and each byte has its own address, a numeric value that identifies that byte. So say on a system with 1 GB of RAM, the first byte has address 0, the second byte has address 1, the third has address 2, 3, 4, 5, and so on, and all the way up to, in the case of a gigabyte, well, it's going to be 1 billion something is going to be the address of the last byte. And these bytes are all addressable by the CPU, meaning if the CPU wants to read or modify a byte in RAM, it specifies the byte by its numeric address. The second important characteristic of system memory is that RAM is volatile, meaning that as soon as a RAM chip loses its steady stream of power, the content of the RAM gets scrambled. None of the bits can be relied upon anymore because without power, they basically get flipped in random ways. So in practice what this means is that when you turn your computer off and then turn it back on, the contents of memory are totally a jumble. It's just basically garbage. So that explains why every time you turn on your computer system, the operating system has to be loaded off of a hard disk into RAM. Despite this annoying characteristic, we still use RAM chips for system memory instead of, say, a hard drive because, relatively speaking, RAM chips are much faster, a good order of magnitude faster, if not 2 orders of magnitude faster. In particular, RAM chips have the property that if, say, you want to read the first byte of memory and then immediately next read the last byte of memory, this can be done with RAM chips just as quickly as reading first the first byte of memory and then the second byte of memory. This is not true, say, with a device like a hard drive. Bytes in a hard drive are stored on the surfaces of these magnetic platters, and these platters are read and written by these heads, these metal mechanical heads. And so to move around the surface, the cylinders spin and the heads have to move up and down, and that just takes time. And consequently, hard drives are much better at reading the bytes which are immediately next to each other on the magnetic surfaces. But if you want to read some bytes which are not contiguous on the platter surface, then that's going to require moving the head around, and moving that head takes a long time relative to the other operations of the system. With RAM chips, it really doesn't matter if we want to read or write a whole bunch of bytes which are immediately next to each other, or if we want to read or write a whole bunch of bytes which are scattered throughout the RAM. All that really matters for speed is how many bytes we want to read or write, not where in the RAM they're located. The same definitely can't be said for most other storage devices, like namely hard drives. So, by virtue of RAM's performance characteristics, and also by the fact that it can be directly addressed by the CPU, because of these properties, we always use RAM to store the code and often much of the data of any running program. Now, while it's conceivable you could have a computer where the CPU reads its instructions directly off of, say, a hard drive or some other storage device, but because the CPU can directly address the bytes of RAM, and because of the performance properties of RAM, it's natural to use RAM as the place to store all of the code of any running program. So in practice, in a computer, when you have a running program, all of the code, when the program is actually running, it's copied into RAM. That's where the CPU reads the code to execute. And while a program runs, it needs some place where it can store data that it can get at quickly, and so naturally the primary choice is RAM. Of course, anything which the program wants to store on a permanent basis, like say if the computer loses power, that has to be stored on a storage device like a hard drive, but the first choice of where to put data is always directly in RAM along with the code.
If you like this video, so please subscribe my channel and like React video.